probability. Uniform, continuous distribution. So the key property with the uniform continuous distribution is that every outcome is equally likely. That's what is meant by uniform. And it can take on any value inside of that. So, and it can take any value inside. So this is defined by two bounds. You have a lower one and an upper one. And if x is between these, it's equally likely. If it's outside, then it is not, it can't occur. So the shape of the graph, so we have A and B. So what's going to happen is, if you're between A and B, you have an equal likelihood of occurring. So your distribution is on. And if you're outside A or B, then you have no chance of seeing it. So this is 0. This is 0. And it's off. This is the graph for the PDF. So shuts on, it turns on at A, and then turns off at B. And outside of them, it's off. So there's a formula for that. We'll get to it in a second. Now for the CDF. So this is the cumulative distribution. And so what we want to have happen with this is so it's going to be 0 coming up to A, and then at B it's going to be 1. So this is 1 and this is 0. And in between here, it's going to increase from 0 to 1 with a steady slope. Okay, so the formula that describes this behavior, so the other piece here is we want this area in this box to be 1. So we have a width here of B minus A, right? That's B minus A is the width. And so to adjust for that, we need a height here so that the area is height times width, and that will end up being 1. So the height here has to be 1 divided by the width, whatever it is. So our height is 1 over B minus A. Alright, so these properties are going to help us define what this function looks like for the PDF, the formula for it. So we want it to turn on when x is between A or B. So it's on there, and it's going to be off when otherwise. So when x is less than A, or when x is greater than B. And so when it's on, it's going to be 1 over B minus A, because that's the height we need. Sorry, height is 1 over B minus A there. Okay, so if you integrate this, you'll end up with a function that is described here. And this is the formula for the CDF. So when x is less than a, it's 0. When x is greater than b, it's 1. And then in between is where it changes. So we have this slope, which is our height of the PDF function, and then it's times how much x has moved past a. So it's x minus a divided by the height, or the total width. So as x goes to b, then you have b minus a over b minus a, and you have 1.